We're live now, by the way.
Yeah.
Oh, wait. Were you supposed to start this, or was I supposed to start this? I forgot.
Why don't you start?
Okay. I think that makes sense. Hey, everybody.
Consummate professional.
No, let's not imply that. Hi, everybody. My name is Denny Lee, and we have yet another wonderful Delta Lake webinar. This time, it's actually with our friends at Scribd, with our Tyler Croy. The session, just in case you can't tell from the title slide here, is Cloud Native Data Ingestions with AWS Aurora and Delta Lake. And so before we dive right into it, and of course, for all you folks, chime in with your questions that'll pop up. Even though we're using StreamYard, we're going to see them through either through YouTube or through LinkedIn. So, Tyler, why don't we start off with, why don't you tell a little bit about yourself, being that awesome Delta Lake maintainer that you are, a little bit about, Scribd, and a little bit about the context behind this, so we can dive into it. And again, for all the audience, by all means, ask your questions. We may or may not answer them, depending on how we feel like it, or if you bribe us. I'm sorry, did I say that out loud? My apologies. But yes, Tyler, why don't you introduce yourself?
I'd probably answer him, whether it's a good idea or not.
Technicality. He will take Celsius drinks as
caffeinated beverages.
Yes. Yeah.
So I work at Scribd, as Denny mentioned. Scribd has, I will say, the honor. Normally, I would be a little more humble and say dubious honor, but I do think it is an honor that Scribd took a risk in late 2020 and created the Delta Lake Rust bindings. We initiated the project. We open sourced it very, very early on, because we wanted to build a bunch of things with Rust, and we really believed strongly in the platform that was going to offer us. And since then, it's been incorporated as part of the Delta Lake project. It's grown and grown and grown, which has been fantastic. Scribd as an organization, we have 3 brands, and let me just, I have a slide.
Yeah, so why don't we just jump right into it? Yeah, that is the Haya. Yeah.
So I'm going to focus on this first. Scribd started as a document sharing service. That was how a lot of people came to discover us. But as we've grown over the years, we've figured out, we've become all about the written word, audiobooks, ebooks, documents, things like that. We also acquired a number of years ago SlideShare. So now we actually have 3 brands. So the company's grown, and our product surface area has grown quite a bit, with Scribd for user-generated documents and uploads, things like that. Everand, which is where you can get a great catalog of ebooks and audiobooks. And then SlideShare, which has a lot of slide content, things like that. But the genesis of this work really came from this two parts of this. One is I'm trying to put Rust everywhere I can. I'm one of those annoying fanboys who's like, Rust is the solution to all of our problems. We just might not know it yet. And I also am very passionate about improving efficiency. And in an AWS environment, which Scribd is in, efficiency can take a couple of different ways. I strongly believe that the best wins are to be had on the architecture side of things. And so Rust plays a role in that. Delta Rust plays a tremendous role in that. But it's really about how we architect things to be efficient, rather than trying to find the most optimal instance type or, silliness like that. And so I wish my co-presenter Kuntal was here, because Kuntal and I have worked together for a long, long time at Scribd. He is always down for some of my shenanigans. Unfortunately, he is not available today. So I'll have to be presenting his point of view. But Kuntal has similarly enjoys making things more efficient, similarly enjoys making things better architected in our infrastructure. And Kuntal also actually introduced Aurora, which we're going to talk a little bit about today, at Scribd to solve some of this problem originally. And so let me jump forward a little bit. Are you with me thus far, Denny?
I think so, but I did.
Tyler loves Rust. Kuntal's not here, unfortunately. Aurora is cool. We like to save money. I think that was the gist.
Well, I did also want to call out the fact that since Tyler, you didn't call it out yourself, you are a Delta Rust maintainer. You're basically one of the original creators of it. Yes, you called out the fact that you helped create, but I just want to call out you're a maintainer of the project because of helping to create it in the first place. So for all of us for stations, we look up to you. That's the call out here.
Originally, Delta Rust was created by myself and QP Howe. QP has since left Scribd, and since we created it, QP actually invested early in these Python bindings, which I like Python well enough, but I'm like, Rust is better. I want to do Rust. But he's like, I like Python. People like Python. Why don't we have Python? And so through those Python bindings, the Delta Rust community has actually grown quite a bit. Ian and I were chatting this morning about cutting a new Python release. We've got a number of people that have come and gone over the couple years improving Delta Lake for Rust, but also Delta Lake for Python. And then sort of taking what we've learned in this process and bringing that down a level to the Delta kernel project, which is going to help, like a Golang implementation, Node implementation, Ruby, yada. But it's like, I am very honored to be continue to be a maintainer. But there's been a huge number of people that have made Delta Rust much better, which really speaks to, in my opinion, the value in companies like Scribd open sourcing work like this, because Scribd has definitely benefited greatly from contributions from others. And we continue to obviously contribute back as well. Yeah.
Awesome. So let's dive into it, and we are going to soon definitely I think the teaser I want to ask or provide is that we are going to talk about, especially because you mentioned the Lambda Python. We're going to be also talking about lambdas, and there's this really cool concept of lambdas that if you had told me this 2 years ago, I probably would have just laughed at you, going, "Ha, you're ridiculous." But now it's actually a core component, which I think is amazing. So I think that's is that a good enough teaser? What do you think?
Sure.
All right, yeah. Perfect. All right, boom. Let's get into it.
Okay. So a lot of where this project originated was actually in our movement to AWS, and that's around the time when we created Delta Rust. And the big challenge that Scribd has had, and a lot of organizations have had this at last year's data in ASM. It was last year, the year before. I actually can't remember. Some folks from DoorDash were presenting their solution to a similar problem, which is that we have online data, and I'm going to use these terms, whether or not your organization uses these terms or not, like you get the gist, right? Online data, which is typically relational data, caching, MySQL, Postgres, et cetera, that the web application is using or web applications are using, and then offline data, which we typically think of like a data lake and sort of, ingested data to do big data on, right? And so we have a fairly complicated architecture on the left. For me, it's the left, but on the data production side. So the web application, online databases, caches, models, etc. There's a lot of stuff that is either generating data or updating data that we need to pull over into the data lake on a fairly regular basis in order for data scientists, for business analysts, for everybody that's doing really interesting things in like a Databricks notebook to get at. Like, we don't want them to be lobbing queries against production, MySQL instances, because that's crazy for a lot of reasons. But we also need to archive that data and ingest that. And when we went from our on-premise infrastructure into AWS, we had to solve that problem because we were moving away from Hadoop and HDFS, and we were trying to cloudify some things. We were trying to make it, spiffier. And so at the time, it seemed like it was a good idea what we were doing. In hindsight, it was harder than it is more complicated than it needed to be. But I'll walk you through the hard way first. Denny is familiar with this because Denny actually helped us open source this part of the code as well.
So sure. I'm involved in the part that was harder and to be blamed. Cool. I appreciate that.
Yeah. So Denny's culpable for the bad ideas we had in the past.
Completely fair, actually, in all seriousness. So it's fine.
We knew that we wanted to use Delta Lake at the very beginning. Like, a lot of our early cloud architecture decisions were centered around Delta Lake. We knew that we wanted to use it for a lot of reasons, solved a lot of the problems that we knew that we had coming into AWS. But getting data into Delta Lake Delta Lake format, at the time, the ecosystem was not as rich as it is today. It's definitely grown tremendously in the last 4 years. So we started working on Delta Rust, started working on Kafka Delta Ingest, which is another open source project. And we also created SQL Delta Import. Denny disappeared, so I'm hoping my network is still working. And Denny's just disappeared. But the okay, so Danny disappeared. So the one of the things that we open sourced was SQL Delta Import, which was written primarily by a colleague of mine named Alex Krishnier. And what SQL Delta Import really did was just connected to a JDBC, uses the underlying JDBC driver and turned JDBC into data frames that we could then write to Parquet or write into Delta Lake format. Fairly straightforward from an architecture standpoint. You can find this now. This is actually not the README, but you can find this in the Delta connectors repo. And we created it, open source it. This is how, for the last 4 years, relational online data has come into Scribd's data lake. Every night, just using SQL Delta Import to copy some stuff over. And it works really well unless you have a ton of data. And
hey, what do you mean by a ton of data, Tyler? I'm just curious.
So, larger than a few kilos, maybe, no. So a ton of data, it can go a couple different ways. You know, hundreds of tables, I would qualify as that can lead to challenges, or tables that are extremely large. And when I say large, I'm talking about hundreds of gigabytes of data for one table, stuff like that. And one of the challenges that we had faced is our data scientists wanted copies. They wanted full copies. And so what they were effectively asking us for is, give me a copy of the entire database every night. Okay.
Sure, no problem.
I guess we'll do that.
It'll fit on your laptop.
Your wish is my command. Yeah. I mean, for a lot of reasons, it was beneficial for them to have a full copy. Scribd is, I think, 17 years old at this point. Our relational data model is organic in nature, to where you might not know what tables you need to service a particular query on the data analyst side. Until you hit that problem, and then you just want all that data to be available, right? And so when we started to set up SQL Delta Import, we realized that if we want to get this done in our nightly batch, we have to get super distributed with the Spark side of things. And because of the nature of the problem, that means that the source data has to be super distributed. And so Kuntal introduced Aurora. We weren't using Aurora. We didn't move into AWS with Aurora. I don't remember why exactly, but we had started with MySQL instances in production, and we didn't want to crater our production MySQL instances. And so what we actually did is we set up Aurora replicas, so MySQL, then to Aurora replicas, and then our Spark nonsense that just hammered the hell out of the Aurora replicas. And the cool thing about AWS Aurora for this type of problem is reads can scale. Due to an architecture decision that AWS made, reads can scale to infinity. You can auto scale reader replicas off of an Aurora cluster because they will share the same underlying storage. So you can just scale way crazy high. And so the reason that this is the hard way is we basically introduced a fairly tight coupling between the Airflow jobs that were running SQL Delta Import to proactively scale up the Aurora cluster. So the Spark job would kick off, and the first thing it would do is blow up the Aurora cluster. So it became, big and strong. And then we would start hammering the shit out of it with our SQL Delta Import queries so that we could get this done in a reasonably, in a time efficient fashion.
Sure.
There are a few downsides to this.
I could gather, yes.
As you might imagine, running replicas of your full infrastructure, relational infrastructure, just to hammer the shit out of it for a couple hours a night is expensive.
I would have guessed.
Auto scaling Aurora up and running dozens, or I don't remember how big, we would auto scale. That you're also paying for a bunch of Aurora, read replicas at that point. And you're also paying for a whole bunch of Spark workers to run and consume this data. And so not the most cost effective, but pretty straightforward. It got the job done. It got the job done for 4 years. Sorry about that. It got the job done for 4 years, more or less. what we discovered running this for a long period of time is sometimes replication just stopped working properly. And when the Aurora replica got out of sync from the MySQL primary, we basically had to just rebuild the Aurora replica.
And fun.
so
Okay. Yeah.
Basically once a year. Looking back in history, we did this. This happened about once a year. We never could figure out why replication would get so screwy that it just could not be resumed effectively. And so we would just rebuild that Aurora cluster once a year from a snapshot.
Oh, interesting. Okay, gotcha. All right.
Which was time sensitive. The nature of this sort of like scale up Aurora, import everything, also meant that like one of those Spark jobs that corresponds to like one table could also block the entire nightly if it failed.
Oh, like, sweet.
Like connections reset. The cloud was being silly that day. So the whole nightly thing would fail, and we would have an incident where, you know, data platform engineers would scurry and try to make sure that they could like rerun the task as quickly as they can before anybody noticed. The other thing,
so that's a bad thing, right?
That is not a good thing.
Okay, gotcha.
Not a good thing.
All right.
One of the things, when I think about cost and when I think about efficiency, I also highly value my time. I highly value Kuntal's time and the time of the other members of the data platform team. And I really want to make sure that we are spending our time on like valuable things, not keeping the lights on, because that's silly. And so one of the other things that was like unnecessary toil was we had a big list. It was a YAML file. It's always a YAML file. We had a big list of tables that would be imported. And so when application engineers go and create a new table, then they would have to go add to that big YAML list so that they could go see that table on, you know, in the data lake. And there's at least 2 or 3 copies of like, if you add a table here, you also need to update this and then this, and coordination and pull requests and deployments and things like that. And so it'd be like, there's just unnecessary bookkeeping that went along with this. Last year, the core infrastructure team migrated to Aurora. So we got rid of the MySQL, you know, instances upstream, and we switched those to Aurora. And so the window opened to get rid of the Aurora replicas that we had. And so Kuntal and I started chatting about some different ways that we could improve this so that we would not have to care about this as much.
Right.
So expensive, time consuming. So, I mean, we still got the data, like all said and done, like people were happy with the end result. Just as the operators of the system, we were not as happy with the result. And we basically,
well, I mean, you're trying to save money. You're also trying to simplify how you manage and maintain these systems yourself, right? I mean, that's what it boiled down to, right? Great, you hit the initial requirements, but you recognize, hey, this is starting to get expensive and really hard to maintain.
4 years ago, we met the requirements 4 years ago.
Right.
Scribd is now a very different organization. The cloud is a very different sort. Like so much has changed in the interleaving 4 years that it definitely was time for us to like reconsider. Like, what if we approach this a little bit differently? Now that the world is a little bit different. So I love a Lambda.
Yes, we're certainly implying that a little bit. Yeah.
One of my pieces of set dressing is Delta Lake, the definitive guard, where chapter 6 or 8, I don't remember what chapter. I actually wrote
chapter 7.
Chapter 7, sure. Chapter 7.
You wrote the chapter, man.
I wrote a little bit about doing Rust and Python for Lambdas, and a lot of that was actually informed by this side project that I had created called Oxbow.
Yes. By the way, this was just to pause, Tyler, for a second. This was a shameless plug for Delta Lake Definitive Guide. Just want to call that out. That we did not actually plan, but as you can tell, we still do it. So just
I'm very proud of the work that you and Scott and Prashant and Tristan, like y'all did a great job. It is a very good book. I have a number of colleagues that read it over the holiday break. So I do think like if you want to understand the depth and breadth of Delta Lake as a technology, I think it is a really good resource. But it does talk about building Lambdas. Like I wrote about building Lambdas in there, largely informed by something that I had created year and a half ago, 2 years ago, I can't really remember, called Oxbow.
About 2 years ago now, actually, yeah. Because remember, like I was saying, when we were just 2 years ago is when we started having the discussion of lambdas. And so now the teaser that I started in the beginning, this is when we had this discussion about this idea. Hey, we're going to use lambdas for table transactions. And I'm like, are you nuts? That's crazy. And so I'm a database guy myself, by the way. So I used to work for the SQL Server team. So this idea of like us using lambdas for like basically a serverless, applicationless, system for transactions. That's just ridiculous. And then, boy, have I been proven wrong, big time wrong. This is why I'm so excited about this stuff, because it sort of blew my mind that this was even possible, right? So.
One of the reasons why I was super keen on Rust for Delta Rust in the beginning is it can be very small. Rust can be a very small from a footprint standpoint. Lambda as a runtime environment encourages you to be small. Like, you pay for the memory you use and how long your thing runs. And so there is a strong economic pressure, I would say, on having as tight and fast of a Lambda as possible. And a couple of years ago, when I wrote Oxbow, there was things like Kinesis Data Firehose has this output conversion where it can just produce Parquet files for you, or like Fivetran or Airbyte, or a lot of these tools that exist for data export can just produce Parquet files. And that's half the battle with Delta Lake, is you need a Parquet file and then a transaction. So it's like, what if you give me the Parquet file and I'll just update the metadata for you? And so we had actually deployed Oxbow for an Airbyte deployment. Airbyte's open source. It's a really useful tool. Check it out if you're not familiar with it. But we basically had external systems producing Parquet that we are bringing into our infrastructure. And then we would just turn those into append-only Delta tables. And then somewhere along the lines, I don't know if AWS mentioned it to me, somebody else mentioned it, if Kuntal mentioned it, somehow word got back to me that Aurora can actually just make Parquet files. And I was like, whoa, what new feature is this? That's amazing. How exciting. And then I went back and I looked. This actually, this has been around since since we started using AWS Aurora. And I had never known about it. So
technicality. It's fine. It's fine.
It's a really, fantastic. But don't get
me wrong, it's fantastic, but you have to admit, back in 2020, even though that was the beginnings, for Delta RS to begin with, I don't think we would have thought back then, oh, let's go ahead and use Aurora Parquet files. We would not have put two.
We were not ready. We were not ready for the information.
Right.
That,
like, hell, like I said, 2 years ago, I certainly wasn't ready for that information. I just laughed. That's all I did. Right. So
it could just give you Parquet files.
Yeah.
Super cool. Fantastic. Yeah. So Kuntal and I, armed with this information, set about hacking some stuff into place really, really quick. He helped me with some of the Airbyte infrastructure. Originally, we sliced and diced some of the Terraform stuff, and we actually got a proof of concept working really, really quickly. And we're really excited about this and convinced a bunch of people that this was A, a good idea, B, it would be cheaper, and that we should spend actual sanctioned development time on it. And so we deployed Oxbow with Aurora snapshotting into testing and staging environments. And it kind of looks like this. So don't be afraid. Denny, this is a lot of boxes. Okay, don't be afraid. This diagram was created by a former colleague of ours named Max. And he was like, you're doing what now? I need to understand this. And so he's charting, he's listening as we're talking. We're like, no, this goes into there and that goes into there. And he's like, okay, and then what happens? And then what happens? And it feels very complicated conceptually if you forget what we were doing before, which was we had Spark workloads orchestrated by Airflow that were dynamically scaling up an Aurora cluster that was a replica of a MySQL cluster in order to do the same workflow. So this is actually, I don't have a good lucid chart diagram of what the world looked like before, but this is simpler than what it was before. And there's a lot of benefits that come with this sort of serverless ingestion pipeline approach. One is that the pieces are much smaller. And so if you think about I'm going to say at this point, mythical Unix philosophy of like, you have one thing that does a thing and does it well. That is what this architecture now is that we don't have the replicas. We can just read straight from, or not read, but we can just use the upstream Auroras, because we're not actually reading from them. We're just saying, Aurora, give me your Parquet files, and AWS Aurora is like, great, I'm going to just start dropping them into the S3 bucket. And so on a nightly basis, what happens is we say, hey, you created a snapshot. That's wonderful. We love snapshots. Good nightly practice for anybody that's running Aurora or RDS. Turn that into Parquet into this bucket. And so Aurora happily goes and does that. We don't have to worry about that working or not. AWS promises that it'll work, and we believe them. So we'll just assume it's 100% perfect all the time. And then it drops those Parquet files into an S3 bucket, and then we can start doing like the Oxbow things around it. Some of the reason that we have a little bit of a complication here is our customers don't like, tables will start to light up, like new partitions of tables will start to land in the Delta Lake or in the data lake as different tables go through this process. But our customers need to key off of like, when is the export complete? And so there's like this branching out that happens by nature of being serverless, that we do actually still need to have sort of a join point back at the end to say, if you are expecting a singular consistent view of what the exported database looks like, now you can execute. There are some workloads that are just like, I just need to know when this table is updated and then I'll execute. But there are a number of workloads which just need that join point to come back in. And that's where Kuntal had done a little bit of step function juggling.
Okay, so
in order to make that possible.
Just to make sure we're all on the same page. So then the complexity isn't actually the process by which for you to export the data, because it's part of Aurora, and nor for you to read that data a la Delta RS, Lambdas. The complexity here is really about the fact that it's more about the business logic of your infrastructure on how in essence, it's like a simplified version of your Airflow right now. That's actually what we're really looking at.
Yeah.
So,
yeah.
Right.
One of the ways that we were importing things before was basically an insert overwrite. And so the view that a lot of people had was an unpartitioned flat table that just got nuked every night.
Right. So you would just nuke the partition, chuck the data in, basically.
We made a slight modification here in that the output for these Delta tables is now date stamp partitioned, so that rather than relying on time travel to unwind versions of the database, if you're comparing like what does yesterday look like to today, now there's actually DS partitioned data in a Delta table. But we didn't want to go update a bunch of jobs way further downstream that expect a unpartitioned table to just have the latest stuff in it. And so we actually did some juggling, and Pavlo, who worked on this project along with Kuntal and I, had to really finagle this to where we do use Databricks. So a lot of our query side of things is Databricks. We actually have Unity views that we slipped in. So the new pipeline goes to the new location, right? And so we had both pipelines running for a period of time. And then we did the old switcheroo where we took out the old database, slipped in a view before the next jobs ran. And so people were actually hitting views when we did the migration. And so we actually migrated a bunch of tables piecemeal, even though the whole database was still being exported every single night through the old mechanism and the new mechanism. And that turned out to be a really useful tool. I mean, we hit some paper cuts with Unity, but we have never really used views substantially before. And so some of those paper cuts were inevitable, but using views in that way allowed us to sort of maintain that API, which a lot in your Delta table schema is in a lot of ways an API between consumers and producers of a data set. And we use that as a sort of shim to allow us from an infrastructure team standpoint, just to completely change everything behind it and not do any disruption to the business. So it was a little hokey at first, as we were figuring it out, but we swapped out the entirety of our online to offline data ingestion in the span of maybe like 2 or 3 working weeks as we were like migrating batches here and there. and it worked out tremendously well.
No, I completely get it. I used to, old school way was basically I would rename the tables into something else, but then create the view with the original name of the table. So that way, whatever processes I was running would just simply hit the view and it would act like, oh, it's perfectly fine. Meanwhile, I'm restructuring the whole table to God knows what underneath the covers, but to the process.
That's kind of what we did.
Yeah. The process systems are like, okay, whatever. It's the same thing. I don't care. Yeah. So I completely get it. It's a natural way of doing it. We're basically abstracting away, quote unquote, for what your processing engines, or your processing systems.
Yeah. Actually, we haven't done it with other projects yet, but I really am liking that pattern of like our job is to efficiently ingest data, or like we own the bronze layer, and so whatever we want to do at that bronze layer, we're going to do whatever we got to do. We might need to change table structure. We might need to change different partition layouts, enable different Delta features, but slapping a view in front for these legacy pipelines that we don't really want to go through this long tail of pipelines and update them has made things a lot easier, because we like every pipeline more or less depends on this online relational data coming in. And we didn't have to touch any of those. There's a couple where there's some schema mismatches, and I'll talk about a little bit about that later, that we did have to touch. But we were able to make this effectively at the bronze layer change without going and modifying a bunch of pipelines, because the data was largely the same, and we had that unity layer where we could control sort of that front door to the bronze table, which worked out pretty well.
Oh, pretty cool.
Yeah, I mean, one of the like I was saying at the beginning, like the opportunities for efficiency in the cloud are more driven by architecture than anything else. Like
right.
4 years ago, Unity didn't exist. Glue data catalog existed, but didn't really support Delta in any meaningful way. Like we would not have been able to do this 4 years ago. I don't think we would have been able to do this 2 years ago if like all of these pieces, or if the Delta Rest side of things existed. I think 2024 was like the perfect confluence of a lot of technology maturing around lakehouse architectures and how these cloud native data components like Aurora or Elasticache, et cetera, integrate or produce data, which is really exciting. Like, super excited about what we've done.
So why don't you showcase the numbers, because you're always good at that. You're always showcasing cost and performance. One thing, by the way, if you haven't listened to one of Tyler's sessions before, which is a shame because really you should, but is basically everything that he ends up talking about, like his obsession being a station in the first place, is all based off of what did the performance numbers tell me and what did I in fact decrease the cost. If I can do those two things, then I've succeeded. That's the only time I'm going to know that I succeeded, because I got the performance faster, I got the cost down. So please show me the numbers.
Well, I can't show you exact numbers, but I can show you graphs with unlabeled
you can show me
axes.
You can show me percentages, which is fine.
Okay.
That's still a number. Percentage is still a number, right?
So before we had to run Spark clusters, right, to ingest all this data. And so this is the last few months of we tag everything. You should tag everything. If you do anything with anything that looks or smells like a cloud, add tags. With AWS, one of the things that we have done is we use a project tag, and that becomes a cost allocation tag. So I can go look at like the SQL Delta import project and just see all of the resources associated with that project in Cost Explorer, which is very important. So the reason we have small numbers in December is because we stopped doing this halfway, or in the first week, I think, of December. But we had way big numbers. Imagine to your heart's extent how big those numbers actually are. And then they became small numbers on the just cost of running compute infrastructure to import this data every night.
And to confirm, just to make sure everybody's, just go back to that slide. It's not like you had less data, right? This is because you had a sizable chunk of data, and because of the switch that you massively shifted down. I just want to make sure everybody's on the same page.
Scribd continues to grow, which is a wonderful thing. We, the product continues to evolve, get better and better, et cetera, et cetera. Most people who are responsible for data infrastructure know that data volume is never flat. is never flat.
It goes up, like, or your business is screwed if it goes down, right?
Yeah, like if it does this, you're like, oh shit. But so data volume through this period of time continues to do this. I don't know what the slope of that line is, but it's a positive slope, right?
Right.
And so to go from growing cost, continually growing cost with growing data volume, to have this massive change in operational cost, that's a big deal. That's the sort of thing that does like genuinely get me excited about some of the work that we've done with Delta Rust. Is these sorts of things pay off in big ways for the business, but also we've done it consistently. One of the first things that a colleague of mine, Christian Williams, if you go back, I think it's to 2021 Data and AI Summit, presented on Kafka Delta Ingest. We cut our streaming ingestion costs over 90% by adopting Kafka Delta Ingest. And so to have a team, and I'm very proud of the work that we've done at Scribd in this regard, to have a team that is consistently like order of magnitude improving costs, it means that we get to, like, it doesn't mean that the AWS bill also never does that. The AWS bill is always going to grow for a lot of reasons. But if you were to ask someone, if you were to ask a data scientist, would you like to spend $100,000 a year on importing data, or would you like to spend it on doing something innovative and interesting that's going to drive the business forward in a meaningful way? They're going to choose the latter always.
Of course.
And the negative space above that small number goes to fund more interesting stuff. And that's also really exciting, is to see like, hey, because we are saving over here, we can invest over here in these really interesting large language model type products, or interesting data processes, things like that.
No, absolutely.
Like that.
Yeah. So I just wanted to overemphasize that point, that because it was December, so it's like, what? There's nothing going on Christmas or something.
No.
So
we didn't take our data infrastructure didn't take a holiday break.
No, obviously not. But yes, please continue. Yeah. Sorry.
So our RDS costs, I don't have numbers for these. We actually are probably going to finally shut off some replicas this week, maybe next week. Okay. But these numbers the big numbers to run these replicas also disappear entirely, because we don't need that infrastructure anymore, because we can just take snapshots directly from the primaries. And so back to the point that I was making about architecture, what's really exciting about architectural improvements of efficiency is removing entire systems. That's where you get big cost savings, is just removing entire systems. And so when we were talking about this internally, there were people that asked like, well, how much? Okay, so we've saved money here. Like, how much does it actually cost to operate the thing? And I hadn't really looked at it, because I'm I'm brash. I'm an egomaniac. I'm like, no, it saved money. I promise, it saved money. Like, come on, like I saved money. And so Kuntal and I were looking at this, and we added it up, and the entire month of December, or forecasted month into January, of running this Lambda-based infrastructure is less than we were paying on a single day to do data ingestion. Like, it was actually cheaper than I thought it was going to be, because sometimes these things are hard to estimate.
I just love the recurring theme, because I still remember, I think I was talking to QP about this, right? When he originally created Delta Rust and with you, right? It wasn't even about saving money initially. It was just like, it'll be cool, right? Yeah. And then it turned out, oh shit, how much money are we saving? And so now you're telling me with Lambdas, literally 1 month of Lambda costs us less than 1 day using the previous architecture. That is, that's a tad bit substantial. Okay, I'll give you that.
It's a big deal.
Yeah.
It's a big deal. We knew that removing Aurora replicas was going to make a big dent. So there's always a couple of things that come into play, like the maintenance of this infrastructure. Now that we've been running sort of the new world for I want to say about a good solid month, especially over the holiday break, things have worked exceptionally well. We're very happy about it, but there are warts. Like, nothing's ever perfect.
Sure.
The only like instant level thing that happened was AWS actually threw us a curveball.
Oh, okay.
And in that Sometimes they just decide to export things that we weren't expecting. And so if it looks like it's supposed to be a Delta table, the way that some of this architecture works is it's like, if you put Parquet files in this directory structure, I'm going to say, hey, that looks like this should be a Delta table. I'm going to turn that into a Delta table.
Right.
And the export Parquet stuff inexplicably created some temporary data at one point, which we were like, whoa, what is this? And so we just had to exclude it. We have some tooling in our Lambda infrastructure to say, like, these prefixes are actually BS. just ignore them, because you have zero control with AWS Aurora's export process.
Gotcha.
It is going to dump Parquet files into whatever your prefix is, like /1/ I don't know why it's 1, but /1/ database.full table name /blah.parquet. And one of the other things that it does, which is really weird, is the Parquet files are like whatever size AWS decides. There's no consistency whatsoever. It's like you have a prefix in the directory, or in files in that prefix that are like from like 5 megabytes to 100 megabytes, but there's like 1,000 of them and they're all differently sized.
Oh, so you don't even have a small file problem. You have a variable size problem now at this point.
It's AWS is just reaching into their pocket and just like throwing Parquet files out, and wherever they land, whatever the size they land, you just have to deal with. And so we do actually have some Delta optimization stuff that comes in when we do that funnel back in. We actually do some optimizations because the query time performance is important to us. We do want to not have small files in our Delta tables. And sometimes AWS just does things weird. That is sort of the nature of cloud native infrastructure, is sometimes they're also having a bad day, or, they're having a bad day, or somebody deployed a derpy thing to your region and, something goes wrong. We've seen a couple of things like that, but it's never like been an existential crisis, never been a problem. It's been like, instead of an hour or two, which is faster than the old system, it's going to take a few hours, and it's still within our tolerable SLAs. But it's not, we haven't figured out with AWS why that happens sometimes. It's like, this feature is a really useful feature of RDS, but it's like off to the side. It's not sort of their primary bread and butter, obviously. Building a database is their primary bread and butter. And so you don't get a lot of configuration. You don't get a lot of tunables. There are some CloudWatch metrics that you can get, but you don't have a huge insight into what happens on the other side of that curtain with AWS. Right. And that's kind of the case with any sort of cloud native technology that you adopt.
I mean, that's the whole point.
You sacrifice
there's an SLA
control
that's supposed to hit, right? And then provided it hits the SLA, then basically you're supposed to build systems that can handle it. That's it.
Yeah.
So, No, I mean, in all seriousness, I mean, it's a good call out the things that could go wrong, but I don't think anything here was like horrendously or horrible. Just, it's more like, okay, just be watchful. That's really it here.
Scribd tries to do better every week, every year. And one of the things that we've had since the beginning in the infrastructure engineering org are, we typically have run books associated with services. And so we basically had to take the run book for the old way of doing this and throw it out and write a new run book, because there's a new set of sort of weird things that can happen. And as long as everybody that's supporting this infrastructure sort of has a general understanding of like, oh, AWS did this funky thing, this is what you do in that case, then it's not that big of a deal. Like, there's always going to be bumps in the night. And
the fact is, like, especially for the literal massive cost savings, and even as you noted, like, maybe the graph again looked a little bit more complicated, but it really isn't, right? Because again, it's that's more the business logic, right? So in all seriousness, that's a simplified flow, not right. So in other words, it's easier to maintain, it's easier to deploy, it's cheaper to run, it's more performant. It seems to me like, if these three things are your major problems, honestly, this is like it sucks when you found them, but still, this is relatively minor compared to any that I've built. So
there's one other that I don't know if this is things that can still go wrong, because this is more of a us problem rather than a this architecture problem. There exists a table that should not exist
Of
in
course.
a relational database
Of course.
that has grown from GBs to TBs, and that presents some challenge with going through this export process. It basically was gumming up the works. Like the order of magnitude jump from GBs to TBs, that's gigabytes to terabytes. In case you know you're not picking up what I'm putting down, is big enough to where it challenges some expectations that we had in this architecture. To we actually just excluded that table because A, we don't need it. B, it should go away. No, like having TBs of data in an online relational database is always cause for concern. And you should maybe like reconsider what you're doing. But we did exclude that because like how big data can get, like hundreds of gigabytes, I'm not super worried about. But once you get into like terabytes of online relational data, this architecture can work, but like the sizing of things needs to change.
Right. Yeah. So for example, I completely understand. So one of my past lives, now this was honestly with Hadoop and SQL Server at the time, but we actually had Hadoop jobs go ahead and query the SQL Server databases, and it was a lot of data, but we were actually reliant on the fact that it was inefficient, so it would only use 1% to 2% of the CPU when it was doing the extraction. So the extraction actually would take a long time, right? So even if it's like we were literally extracting hundreds or thousands of databases, and so altogether we're talking about terabytes easily, like no problem at all, right? Tens to hundreds of terabytes each night. But because it was a production system, and because ODBC was slow as shit, basically.
Oh
yeah. Look, it was great. It was only 2% CPU utilization on the machines. So we're like, okay, pull them out. It'll take you 8 hours, but it's fine, right?
So. One of the reasons why this is efficient, if you think about like ODBC or JDBC or something like that, like in order for the server side to support that, there's like a structuring of a protocol that has to happen there, and then on the Spark side, you have to turn JDBC into data frames, and there's a overhead in that protocol transformation, and then there's the serialization to Parquet, and then the write to S3. Yeah, that part of the pipeline, it's just unnecessary CPU. And so we just slice that entirely out. But one of the things I wanted to mention when we talk about like scaling and data sizes with this, with Oxbow, one of the things that is really exciting about that is Oxbow does not ever look at the data size, because what it gets triggered with is the S3 event notification that says a Parquet file exists over here. And Oxbow can go, hey, great, there's a Parquet file that exists over here. All I need to do is load the transaction log for the Delta table so that I can create an append. It never has to consider the size of that Parquet file. So the Lambda performance side does not scale in the same way. It's more driven by like
from the Lambda side, it's just literally the JSON. Like it's just a transaction log you're creating. That's all this is. And it's especially if it's like, even if it's a large file, it's only one additional like file path you're actually adding the transaction log anyway. So it's like, yay, who cares? Right. So, but from your standpoint though, the actual export from Aurora to the Parquet files, when you're going from a gigabyte to terabytes, that's the one that sort of messed you up, basically.
Yes. So I want to call out one other thing, because Kuntal deserves credit for this. When I first created Oxbow, I was all about append-only tables. Sure. It's like, just take the object created put. That's the event.
Yeah, and then you're done. You're good to go. Yeah.
And Kuntal rightly so was like, well, what about deletions? And so I was like,
good point.
Oh, that is a good point. I was like, interesting. Okay. So S3 can tell me when a file appears, so I can add that to the transaction log. It can also tell me when a file disappears. And so one of the things that we can do with Oxbow, which is really compelling, and we do this for other tables, is you can, with a tool like Oxbow, you can rely on S3 intelligent tiering for a Delta table to remove older Parquet files. And so in the case of we're ingesting this data, right? So we don't need a copy of the database from 2024-04-01, April Fool's Day 2024. So we configure an S3 lifecycle configuration to say Parquet files older than some time period, and I can't remember what the time period is, remove those. And if you were to do that, just on your Delta tables. Don't do that on just your Delta tables. You will corrupt your Delta transaction log because files will disappear from the underlying storage, but they will still have references in the transaction log. Well, Oxbow, you can send it the delete events as well, and it will turn that delete event into a remove transaction on the Delta table. And so your Delta transaction log stays intact, right? And you can have this sort of rolling window driven by the intelligent tiering or lifecycle configuration of that bucket in a way that gives you, files just disappear off the tail end of your rolling window of time without you needing to do anything. And so we actually have this deployed with this import to where before we had jobs that would, when we would do the import, we would rewrite things. And then we had to vacuum because we were pruning older versions, older versions of files, older versions of files. We don't actually really need to do that. We just have S3 expire and expunge older Parquet files. And then Oxbow says like, oh, this thing was removed. And so it removes it from the transaction log, and presto bango, there's no need to run a job to do a vacuum. It just transparently keeps this sort of rolling window of data available, and keeps that transaction log coherent.
Cool. So basically, you're actually able to leverage the lifecycle policies directly when you do this now, which is really nice. Because to your point exactly, if you don't actually understand how that works, basically the lifecycle policies will in fact corrupt your table. In this case, this setup, this configuration allows you to actually leverage AWS lifecycle policies to actually make this a lot more efficient.
When Kuntal mentioned that, my mind was like, even though I wrote Oxbow, because I think one of like big first things that I came to Databricks when we started working together on some of the Delta Lake stuff is like, I need lifecycle policies. I need data to go away.
I remember us actually having that real deep conversation about how we were supposed to integrate that, how we would map AWS lifecycle policies directly as metadata.
I don't need it anymore. You can take that off the backlog. I got it.
Yeah, perfect. We're good. All right. To our PMs, we're good now.
But I was like, why didn't I think of that? And that's one of the things I really enjoy about working with Kuntal and some of the other members of the team is Kuntal has a very DBA like infrastructure oriented background, which is different than my own. And working on the data platform layer, we're able to come up with really novel and interesting solutions because we have very different backgrounds, very different perspectives on the same problem, and that lets you come up with cool stuff.
No, definitely. So one thing I want to add before you get to the last slide, so this approach, obviously we've been talking about Aurora this entire time. Does this approach work for AWS RDS?
So there's like RDS MySQL, RDS MariaDB or something. To my knowledge, this approach works with snapshots. So there's two related features, but they work slightly differently. One is you can take an RDS snapshot, and I think that's the same regardless of your engine. And you can take a snapshot and turn it into Parquet. Okay. The other that is Aurora specific, from my understanding, is you can export directly from Aurora to Parquet rather than taking a snapshot. We structure things off of snapshots. You can actually do something like this outside of AWS as well. So let's say you're running like with Postgres as an example. Postgres, you can dump Postgres tables to Parquet. Like there's a way to do that. You could do that same thing with like a do-it-yourself Postgres installation. One of the things that's really cool, I haven't done this yet, but I do want to try it at some point. Minio, as an example, Minio is an S3, on-prem S3 sort of tool. It's really, really useful. Minio has S3 event notification compatibility. And so Minio, as an example, you can also configure what looks like S3 event notifications. And so what I want to do is I want to take Oxbow at some point and like try it in an on-prem setup because Postgres connects with Parquet and Minio can give you those event notifications. But like anywhere you get those notifications, like Azure has something similar. I haven't done the Azure work with Oxbow yet, but like Azure also has notifications off of ADLS v2 that you can plug in. Gen 2.
I hate the name. Sorry, I've known this name for such a long time. I hate the name.
Azure Storage, Azure Object Storage, does also produce event notifications that you can use to drive this sort of lifecycle. Azure also has Azure Functions, and there are Rust bindings for Azure Functions. Like you can build Azure Functions in Rust, and so this same architecture could also work with minor modifications on Azure. I just haven't done it because I'm not running on Azure. But any way that you can get Parquet out, and RDS snapshots will produce Parquet. I think regardless of engine that you use. I don't know about the RDS like SQL Server or RDS or Oracle, whatever. But I know like MySQL and Postgres snapshots you can take out.
Oh, that's pretty cool, actually. Yeah. And then I guess for any of our Azure listeners, if y'all want to go ahead and build something like this for Azure Functions, definitely
Let's do it.
Definitely ping us. Yeah. All right, we got less than 5 minutes left, so let's get to the last slide and do our thing.
Got questions?
Oh no, let's just get the slide because I think we covered most of the questions right now. So yeah.
Sick. Everything that we have done is using open source or off-the-shelf tools. What we just talked with Kuntal and head of core infrastructure, John, yesterday about was open sourcing the actual Terraform module that we have to do this whole thing.
Sweet.
And so we've got tentative thumbs up on that. So hopefully once we check all the boxes, sign all the blah, blah, blahs, Scribd will be able to open source that Terraform module. But everything's kind of is easy peasy. Just take the things off the shelf. One of the things about Oxbow that I want to mention, when I first wrote Oxbow, it was about taking Parquet files and turning those into add transactions. And it just sort of like snowballed from there because like, oh, well, for some of these things, you need to rename files in order for that part to make sense. And so there's a rename lambda there. There's an Oxbow lambda. We also have some catalog stuff that has to happen. So instead of somebody committing, a file change to say, oh, this now exists, this table now exists, we dynamically say, oh, there's a new Delta table, and that's the glue create lambda. There's a new Delta table that exists. Add that to glue data catalog. There is an equivalent that needs to be done for Unity, but leave that off to the side for now. Or if schema evolution has changed, there's a glue sync lambda. So if a metadata action happens on a Delta table, then what the glue sync lambda does is say like, great, I'm going to go look at that schema. And it actually does that, takes that same schema evolution that happened at the table level and reflects that into glue data catalog so that anybody that's using the data catalog as their sort of source of truth for schema has the correct updated schema as well.
Got it.
And then lots of off-the-shelf stuff. Like,
yeah,
I don't know, the AWS stuff is, I mean, Cloud Native is pretty cool. I mean, there's a lot of stuff that I no longer have to operate, which is what makes me happy. Yeah, I think it's really cool. There's all like, if you spend some time looking at Oxbow, or you get comfortable with this idea of S3 bucket notifications driving Delta workflows, like I mentioned, Kinesis Data Firehose can output data directly. There's a huge number of tools. We've all sort of seemingly agreed that Apache Parquet is a good columnar data storage format. And if you have anything in the world that can just write to S3 and put a Parquet file there, you can have a Delta table.
I know this is so brilliant. I love the fact that this is because we've all agreed on the fact that basically Parquet. I still remember back in the days where we're all like, is it Parquet or is it Orc, or is it right? And for a while the protobuf, right? Or like he's like, no, we're gonna forget for that being a messaging standard. Let's make this a data standard. And you're like, wait, what? Right? So
I remember.
We all agreed on Parquet. So the fact that it's all in Parquet now, I'm just going, I love it. Just with Delta RS, bam, append with the transaction log and or delete. And then you're off and running. This is bloody brilliant.
Yeah, it's super cool.
Well, I think that's it for today. Oh, sorry. You want to answer that?
Yeah. I wanted to mention one thing as well, because I promised Zach I would sort of explain this a little bit. So remember when we joined back together, there's an optimization. So we use Databricks. One of the caveats of this architecture that you should be aware of, you listener, you Denny, is things writing to a Delta table inside of a Databricks workspace have concurrency guaranteed by things inside that Databricks workspace. When you're outside of that Databricks workspace, you do not benefit from those things, but we have the S3 DynamoDB log store protocol that can be used. And so the way that there's actual Databricks jobs that do stuff that run downstream that also, like the optimize thing, we actually run optimize as on a DBR. You can actually just configure a DBR based job to use. It's the same open source Delta, Spark support underneath. So you just configure the log store configuration, which is documented on Delta IO for your Databricks job. And then we have our Oxbow Lambdas and other Lambdas using the same DynamoDB log store as our Databricks jobs so that we are able to safely run those things without somebody getting in a race condition. Because one of the things about this architecture is it's evented. You can't rely on Airflow to say, I'm going to run this, and then I'm going to run this, and then that's going to happen. When events happen, Lambdas are going to run. And so you do need to make sure that you have the sort of concurrency guarantee in place in order for those writes to safely happen sort of when events are happening. But I did want to mention that in that like DBRs can do the S3 DynamoDB log store. You don't have to use the built-in Databricks workspace sort of concurrency primitives. You can just jet out to a DynamoDB that your Delta Rust or Delta Python stuff is configured to use as well to have sort of cross-platform writers.
I actually think we should probably go write a blog on just exactly this, just to showcase. I mean, the documentation's still already there, but just to showcase that. That's all I mean by that.
Sure.
Yeah. All right. But okay, it's top of the hour. I thank everybody for joining today. This has been a really fun session, as you can tell. Tyler and I, we seem to get along, so it seems okay. But I really appreciate your time. If you do have any questions, or we will be sharing the blog post. The slides. We will be sharing the slides, and then. But if you want to chat with us, by all means, join the Delta user Slack. Go /delta.io/Slack, and we're on there, and we're answering questions there all the time. So that's it. Anything? Why don't I give you Tyler the last word here?
I think our data platform team is among the most innovative in the industry. We do have some positions open for people to join. If you go to tech.scribd.com, we have our careers listed there. I would love to work with you. I think there's lots of cool shit we're doing in 2025, and we need more people that want to do crazy things like this.
Absolutely freaking awesome. All right. Thank you very much, everybody. Since we're getting over, we'll see you guys in a couple of weeks for next week for the .NET one. So we'll see you guys then. All right.